Okay, we're going to practice an example using our new confidence interval formula, that being with the t-statistic, which we use for smaller sample sizes. Okay, so we're going to talk about music performance anxiety. So there was this study where they measure how anxious people get when they perform music in front of people. They call this score the Performance Anxiety Inventory, or the PAI, and it ranges from 20 to 80, and they measured the anxiety score for, let's see, 1, 2, 3, 4, 5, 6, 7, 8 people. Okay, so let's look at some of these questions. So we want to compute the mean score, x bar, of the sample. We also want to compute the standard deviation from this sample, from the 8 people. Okay, so let's start with that. So let's just start with the information we know. So we have n is equal to 8 here. So notice that this is a small sample. By small sample, I just mean n is less than 30. So when we have a small sample, we're going to use the t-statistic instead of the z-statistic. Okay, so we need to calculate x bar. So this is going back to chapter 3 material, and there's no need to do this by hand. We can just put this into our calculator, or we can do this in Excel. Same with this sample standard deviation, S. So I'll leave it to the viewer to verify these numbers on their own, but if we calculate the mean from these 8 numbers, I get an average of 45.625, and I get a sample standard deviation of 6.59. So that's just plugging my 8 values into Excel. So I'll just say use calculator or Excel. Okay, so that was parts, I think, A and B. So part A was X bar. Okay, we did that. Part B was the sample standard deviation. We've done that. Okay, so now we're on to part C. We want to find a 95% confidence interval for the average mu. Okay, so let's do that. So we want a 95% confidence interval. So let's just recall our formula. So we have x bar plus or minus t n minus 1 alpha over 2 s over root n. Okay, this was our new formula. So if we want a 95% confidence interval, that means that alpha is equal to 1 minus 0.95, which is 0.05. And so alpha over 2 would then be 0.025. Okay, well, n is 8, so that means n minus 1 degrees of freedom would be 8 minus 1, which is 7. Okay, so we want to look up the value t, 7 degrees of freedom, 0.025. All right, so let's go ahead and look at our table. Okay, these were our examples from before. So what did we say? 7 degrees of freedom. So 7 degrees of freedom, and we want 0.025. So 7.025. Okay, so our number here is going to be 2.36. So this is 2.365. Okay, and now we can just plug in all of our numbers. So x bar was 45.625 plus or minus our t value, which we just looked up to be 2.365 times, okay, our s we calculated to be 6.59. And then we want to divide by the square root of n, or the square root of 8 in this case. Now all we need to do is simplify this, so I get 45.625 plus or minus, whenever I plug that into my calculator, I get 5.51. So my margin of error is 5.51, and so my interval will range from 40.115 to 51.135. And that's our confidence interval. So we have 95% confidence that the mean performance anxiety inventory score is between, 40.115 and 51.135. Okay, so I think that takes care of part C. We just did our 95% confidence interval. Okay, part D. For the interval in part C to be valid, how should the population of PAI values for all music performance anxiety studies be distributed? Well, for this, we know that it should be normally distributed. So we need to assume normal distribution for small sample sizes. And then finally, part E. If you were to repeatedly sample 8 performance anxiety studies and form a 95% confidence interval from mu for each sample, what proportion of the intervals will actually contain the true value of mu? Well, we know that this will be 95% of them, right? If we do this for 100 intervals, 95 of those intervals should contain the true value of mu. Okay, that finishes this example. But you know what? Let's do one more. Let's just quickly do a 90% confidence interval. I would recommend pausing the video and working this out on your own. But okay, let me go ahead and do this. So x bar plus or minus t n minus 1 alpha over 2 s over root n. Okay, well, the only thing that's changing here is our confidence level. So we're just going to get a new t value. So now alpha is 1 minus 0.9, which is 0.1. And so alpha over 2 would become 0.05. We still have 7 degrees of freedom. So now we look up t, 7 degrees of freedom, 0.05. So let's do that. So we're still working with 7 degrees of freedom, but we now want 0.05. So I'm going to go down, so 7 degrees of freedom, 0.05, I get 1.895. So my t is 1.895. And now I'm just going to plug in. So our x bar is the same, 45.625 plus or minus our t value, which is now 1.895, and then times s, 6.59 over square root of 8. Let's continue to simplify this. So our margin of error now is 4.41, and therefore my interval becomes 41.215 to 50.035. So let's just compare this to our interval up here. So notice that our lower bound is bigger than this lower bound, and our upper bound is smaller than this upper bound. So what that means is that our interval got narrower. So narrower than 95% confidence interval. That makes sense because we know that as we increase confidence, the interval becomes wider. Then, of course, if we want to interpret this, Instead of 95% confidence interval, we now only have 90%. And now our interval ranges from 41.215 and 50.035.